In this video, I want to go over an example to talk about z-scores and this idea of standardization we talked about in the previous couple of videos. So I have three different formulas given in the textbook for a z-value, a z-score, and they all kind of represent the same thing. So if I look at this first formula, this is saying x is just one data point minus the average divided by S is standard deviation. So this first formula here would be for sample data. For the population data, Z is X, which is a data point, minus mu, that's the population mean, divided by standard deviation. And if we're doing a hypothesis test, we have the statistic minus the null divided by standard error. But one way to think about it is z-score or z-values are the number of standard deviations or standard errors away from the mean. So one way to think about it, it's how many standard deviations away are the mean is this particular data point. So I want to look at a couple of raw data points. I am about 6'2" tall. My wife is 5 feet 11 inches tall. So looking at this data, I want to know, who is taller. If we just look at raw data, of course, I'm about 3 inches taller than my wife. But relative to male versus female, relative to our sex, in other words, who is more of an outlier? Me at 6'2" tall, or my wife, who is 5 feet 11 inches tall. So I went and looked at, this is a study done by Columbia University, and they compiled and found that men's heights have a mean of 69.1 inches, standard deviation of 2.9, while female in the United States have a height